Okay, we're on enthalpy changes from average bond energy values. And the first one gave you a molecular representation, which we are interpreting to be H2 plus Cl2 yields 2HCl. Okay, now I personally find it beneficial to draw in the individual bonds just because it helps so much since we're looking at bond energy values and we have to know what's breaking and what's forming. Okay, so here you're breaking these two and you're forming two HCl bonds. So when you go to calculate this, you take the bonds that are broken and you subtract the bonds that are formed to get your overall enthalpy change. Okay, so what we're going to do is if you look in the table, table 4.5.2, it tells you that this bond specifically has a value of 432. And I'm omitting units just for simplicity purposes. And then the Cl2 has a value of 243. So you add together the bonds that you broke, and then you're going to subtract the bonds that you formed. Well, you formed two HCl bonds, so 2 times 427, which is the value that goes with the HCl bond in the table, that's going to end up giving you negative 179 kilojoules per mole of reaction. Okay? Okay. Now, for number 2. Okay, for number 2, you are breaking 1, 2, 3, 4, 5, 6, 7, 8 carbon-hydrogen bonds because you have no carbon-hydrogen bonds on the product side. So you've got 8 carbon-hydrogen bonds broken, okay? Then you've got 2 carbon-carbon bonds because there are no carbon-carbon bonds on the product side. So you're going to add 2 carbon-carbon bonds broken, okay? Then here you have 5 O2 bonds that are broken. So plus 5 O2 bonds that are broken. And the reason why I'm writing it as O2 is because in the table it specifies that when it's O2 it has a certain value, okay? All right, then you've got, since there are 3 of those, you've got 6 carbon double bond oxygen bonds forming. Okay, so 6 C double bond O are forming. And then you've got these OH bonds in water that have formed, but there are 4 molecules, so that really means that you formed 8 of them. So this is plus 8 OH bonds formed. You look all of these values up in the table. It's going to end up being 8 times 413 plus 2 times 347 plus 5 times 498. And this is the sum of the bonds broken. And then subtract 6 times 799 plus 8 times 467. And this is the sum of the bonds formed. You're going to end up with negative 2,042 kilojoules per mole of reaction. Last one. Okay, for this one, you have 1, 2, 3 HC bonds that you've broken, okay? Plus a carbon single bond oxygen bond that's broken because you have none over there. Plus, you broke 1.5 O2 bonds. Okay, so that takes care of the broken side. Now, on the forming side, you've got 2 carbon double bonded oxygen bonds that have formed, plus 3 oxygen hydrogen bonds. You have 1 oxygen hydrogen bond over here that wasn't broken, so that's why I'm including it. Okay, so one of these was already done. So I only formed 3 oxygen hydrogen bonds. Okay. When you plug this in, it's going to be 3 times 4.13. Double check me on that value. Let's see. Is that right? That doesn't seem right. It's 413, not 4.13. Okay, 413. And then plus 358 plus 1.5 times 498. So this is the sum of the bonds that were broken, okay? Minus 2 times 799 plus 3 times 467. And this is the sum of the bonds formed. Okay, so 3 times 413 plus 358 plus 1.5 times 498. This is 2344. And 2999, negative 655 kilojoules per mole of reaction.